So welcome you all. So this is PSL 86, 88. So we have conducted so far 87 lecture. It is 88th lecture. So it's being organized by Tamil Nadu Science Forum. So before we getting into our business, let me introduce the Tamil Nadu Science Forum for a while. TNSF, Tamil Nadu Science Forum, is was founded in 1980 by few scholars in Anna University, Madras University, Madras University. It was in the physics department. So few research scholars started this organization, and initially they start conducting some hall lectures, popular lectures, and they also want to gain knowledge about the cross discipline. They bring many experts from different disciplines and start learning. So that's how the TNSF was founded. After some time, they thought that why don't we go out of our campus and go to the local area and explain in local language about the fundamentals of some few science concepts and other things. So it start moving out to different places and they do some activities in the local. Apart from that, they also start doing some demonstration, like the night sky watching using a telescope. So that's how it started expanding its activity. So based on the response, so many people come forward as volunteers to align with Tamil Nadu Science Forum. They started putting membership, and finally it became the actual organization and start functioning with the representatives and elected office bearers. They want to expand their activities throughout Tamil Nadu, and they started going for a science jata. It started in Kanyakumari in 1986, and they went around different villages, and it was culminated at Chennai. It was happened for 3 months. It get an overwhelming response, and the activity science forum has expanded to a different district, and we have now district branches. Finally, all the district branches together started the state level organization. So basically, it was built from grassroots level to the top level, not from top to bottom. It was built from bottom to top. Now the science forum is organized into 5, 6 different verticals. It started bringing the magazine in 1987, Tulit, children's science magazine, and 1991 an English magazine called Jantar Mantar for college level students, and other several publications. Then publication group has separate functioning. It started with the science communication. Then we move to the science publications. And the third activity which we are currently doing is the involving the women in science. So we call a separate group called Samam. So they work on women in science. They encourage the participation of women in science activities, STEM activities. That's the third group. And fourth, we do research on environment and developmental activities. We need development. Simultaneously, our environment should not be damaged. So for which we should work for a sustainable development, and we are working on that. We do the studies and take up the various pollution and environment issues, and we work on that. And also we have a group, separate group work for the education and health. There's two separate group working on education and health. And finally, we work on the youth as well. There are 6 different verticals working under that. So the PSL, the Popular Science Lecture group, coming under science communication. So we are in science communication. So every district we have the different 6 different coordinators to carry out this 6 different kind of activities. And in Chennai district, South Chennai district, we follow the South Chennai district. So this PSL is aligned with South Chennai district, and it's part of the science communication. So coming to PSL, so the popular science activities were carried out, as I said, since 1980 onwards. The science communication group usually go to the schools and they work on the schools. The schools, we form Tulit Club, encouraging the students to read magazines and other our publications, forming a club and discussing the articles. And we also have the Tulip talent test. Every year we used to conduct Tulip talent test. And the third one is the Science Congress, Children's Science Congress. We invite school teachers from different schools. Maybe last year we have 400 school students as teachers and conducted a workshop how to develop the analytical mind of the students, for which we float a theme. Using the theme, individual schools to develop, select 3 or 4 students and do a project. And finally, on Science Congress, we make them to present their project. Based on that, we select a best project and it will go to the next level. District level, state level, then finally it go to the all India level. This from last 2 years, all India was disconnected because they dissolved the science communication department in government of India. Now we do it only at state level. So that is so activities which we are doing in the school levels. Then we thought that we have to expand our activity to the college level. So that is the reason the PSL come into picture. In PSL, we take up all the recent research and the interesting developments that's going on in the field of science. We used to have the lectures, and particularly we are very much focused on conducting the Nobel Prize lectures. Now, every year, a Nobel Prize was announced on the first week of October, starting from the medicine or physiology, then physics, then third chemistry, fourth economics, fourth is the literature, peace and economics. We used to do the first 3, medicine, physics and chemistry. So each year we used to conduct the work done by the Nobel laureates. People who are working in the same field, we invite them to present a lecture on how the Nobel work was very much important. So that's how we did it, and from 2018 onwards, so 6 years, we have 6 into 3, 18 lectures so far we conducted for the Nobel Prize lectures. Other than that, whenever some interesting articles comes up, interesting paper comes up, we bring people here to do that. This is one of the things. This recently I read a paper done by Dr. Arulalan. He has done an extensive work on the climate issues, particularly the heat wave. And he's the one, as I mentioned in my introductory slide, he basically started with physics graduate, then he did MCA, then he moved to IIT Kanpur to work on projects. Then he focused on the climate area, and he did a PhD, finally get into the IMD. He has predicted a lot of the cyclones. He was involved in predicting the landfall point of the cyclones. Last 14 cyclones he has done with a high degree of accuracy. So that will help us to avoid the catastrophe, mitigate the impact of the cyclone that is hitting the land. So I thought that this is an important area which we need to focus on, and I just contacted him, and he readily agreed to my suggestion. And he says that he was placed in Delhi, and he has planned to visit Chennai in March. And he gave a date, and yesterday night only he landed here, and he was preparing the slide throughout the night, and he come here, and he's also going to give one more lecture on the same subject with a little bit more technical aspect on Monday. That's on tea and talk. So now it is time for Dr. Arulalan to take over. Thank you, sir.
Yes, sir. I thank you for inviting me for this lecture. So I would like to mention 2 things. Though I'm from IMD Delhi, so I'm okay. Fine. So it will be 2 mic. Is it okay? Okay. I thank you for organizing team to inviting me to give a talk on my research paper. So I just want to mention 2 things. Like I'm from IMD Delhi. I'm not a spokesperson, so these results are from my PhD work. This is not representing IMD research. Okay, this is the thing I want to convey you. But you can ask me anything, whatever our organization is doing, like whatever the publicly available information I can share. And second thing, this is my public talk. First, my public talk, like common people or normal students. So I'm trying to give my lecture the easily understandable way. So if you are not understanding, please stop me, because if you are not able to understand one slide, then you cannot follow the subsequent slides. So we are going to discuss about the heat waves over India, the plus 1.5 degrees Celsius and plus 2 degree Celsius warmer worlds. Do you know anything about what is plus 1.5 degree? Maybe if you are familiar with the recent newspaper, everybody talking about plus 1.5 degree. Why plus? Yes, yes. So we all know that, like, this is the reason, just representing the actual true picture taken in Tamil Nadu, this rightmost picture. And we all know about the drought and heat waves, and also more than 2,000 people killed in 2015 in India. So this is the question, like, what is X? So we are talking about X plus 1.5 degree. This is the current, like today or 2024 observation. So when we are discussing about this plus 1.5 degree, this is like uh, complete Earth average temperature, which includes both the poles and entire continent and all the ocean temperature. Once we are averaging all the temperature at any time, so that is the average temperature, which is what? That X. So that was 13.7 degrees Celsius during the 1850 to 1900. This is called pre-industrial condition. This is just a representation of how the pre-industrial without any industrial conditions. The moment we introduce, we in the sense the human introduce industrialization, then more carbon dioxide emissions and fossil fuels. So many things happen very, very rapidly, right? Since it has reached already 15.25, that is plus 1.55 degrees Celsius in the last year, 2024. WMO released that, World Meteorological Organization, that's WMO. It is announced that it is the very like warmest year so far, whatever we observed. That is already reached plus 1.55 degrees Celsius. So why, how this plus 1.5 degree came up? In 2015, United Nations on climate change, they brought Paris Agreement. It happened in the Paris 2015 December 12th. So that is the first time, like ever, more than like 196 countries come together and align on agreementing. We have to limit the global temperature up to plus 1.5 degree. Also, we have to try to limit maximum by plus 2 degree warming world. That is the target. So that was the commitment. Entire most of the countries agreed, right? Then, like well below, that's the goal is like the limit global temperature rise to well below 2 degree above pre-industrial condition, right? Whatever I mentioned previously, that's a pre-industrial condition, entire world Earth temperature. If you're adding something due to this fossil fuels or CO2 emission, all the emissions, so that is increasing the temperature, and it should reach maximum 2 degree warming world. And with the effective cap at 1.5 degree, that's a maximum cap we are trying to reach. So also the made that world leaders to urgency like limiting the world to plus 1.5 degree to avoid severe climate impacts like droughts, heat waves, extreme rainfall, or very intense cyclones, all the stuffs. The interesting thing is, like, emission targets, greenhouse gas emissions must peak by 2025. So whatever world is working, whatever you want to further work on your modernization or whatever we call, so greenhouse gas emission must peak. This is the peak year, must peak, and then drop 43% by 2030, the next 5 years, to meet the plus 1.5 degree global. Okay, this is the interesting stuff. This was agreed on 2015. I'm talking about this 2015 agreement. These were the main core agreements among 196 countries. So they were targeting emission targets that greenhouse gas emission must peak by 2025, because like a 10-year or decadal projection they were doing in 2015, like whatever whole country in the world is doing, maximum emission to complete it by 2025, and then drastically reduce up to 43% by 2030, so that the world will meet 1.5. That was their projection. That projection made by the IPCC, that's the Intergovernment Panel on Climate Change. That's a group of government, non-government scientists are working towards understanding the climate. So they recommended, this is the recommendation, and then all the countries agreed upon that. So you see that, but already I mentioned the previous slide, we already reached. In 2024, we already reached plus 1.55 degrees Celsius. So though in 2015, we projected the next decade, it would be like we are targeting maximum emission, and then 2030 it was projected like limit plus 1.5 degree, but we are unable to do, we failed, right? So it's a historical significant. This is the historical, like first time global agreement uniting all the nations to like come back on climate change and adapt to its effects. But a few countries are they already gone away from this commitment. We all know those. And this is the 2016 WMO confirmed that was a very hottest year on record, about 1.1 degrees Celsius above pre-industrial era. If you see the date, it was 2017, they announced that 2016 was the first ever highest temperature record on the earth. So they also mentioned that this has been confirmed the hottest year on record, surpassing the exponentially high temperature of 2015. After 2015, 2016 was the very highest temperature. So you can see that how like, this is just a representation I also took from the WMO citation. So this just says that temperature, you can see that just a representation, this is the dark red color patch shows that record warmest one. You can see that over Indian and even the southeast coast, like Tamil Nadu, Andhra coast, also over the northwest India, including other countries, that darkest red pixel shows that it was the record warmest, which means that is the peak warm or peak temperature was observed. So subsequently, on again WMO confirms 2019 as the second hottest year on record. So 2016 was the first hottest year. Then again 2019, they were declaring it is second hottest year after the 2016. So what they mentioned, like the average global temperature has risen by 1.1 degrees Celsius already since that pre-industrial era. Also, the ocean heat content is at a record level. So WMO secretary was mentioning about that. On also the current path of carbon dioxide emissions, we are heading towards a temperature increase 3 to 5 degrees Celsius end of the century. So this is the thing, it was projected in 2020, based on 2019, end of this century, we'll be reaching 3 to 5 degrees Celsius above pre-industrial conditions. Again, this is next year, 2020 was the one of the 3 warmest year on record. So if you see that every year we are saying that WMO, like World Meteorological Organization, says that this is the warmest year, this is the warmest year, right? And again, 2021 of one of the 7 warmest year on record, right? Though that 2021 was La Nina period, so it was cooled down, that the global temperature was cooled down, but still 2021 was one of the 7 warmest year. So that was their observation. And again, what they did, again on 2022, they mentions 50-50 chance of global temperature temporarily reaching 1.5 degrees Celsius threshold in next 5 years. This was projected in 2022. Okay, in 2022, we are projecting after 5 years or by 5 years, there are 50% chance to reach plus 1.5 degree. Just like 2 years before. Okay. We are projecting like this, but again, so we are in 2023, again it says that we are reaching the like a climate change record we have reached. Again, the WMO report confirmed that 2023 was the warmest year on record. So as I mentioned, like 2016 onwards, once in a year, we are saying that this is the warmest year, right? Again, it was the warmest year on record with a global average near surface temperature at 1.445 degrees Celsius with a margin of plus or minus 0.1 degrees Celsius error above the pre-industrial baseline, right? So this was the condition in 2023. So this is the last year. Again, WMO confirms 2024 as the warmest year on record at about 1.55 degrees Celsius above pre-industrial level. Okay, if you see that just whatever I spoke in the last few slides. So in 2015, Paris Agreement, we were, I mean, all the WM representative countries committed to reduce the carbon emission by maximum emission by 2025 and then reduce by 43%, so that by 2030 it will be limited to plus 1.5 degree, right? But again, we already reached on 2024 itself. Even 2022, it was projected like there are 50% chances to reach plus 1.5 degree by next 5 years, like 2027. But in 2024 itself, we already reached that limit. I mean, we are crossing that limit. So now, if you are talking about when we will reach the 2020, when we will reach the plus 2 degrees Celsius, that also nobody has no exact answer. But as per this scenario, it may reach very quickly. I started this study, my study and their results in 2016. 2015 was Paris Agreement committed by all the country, including India. I started research upon this in 2016. At that time also, I also don't know what is that plus 1.5 degree. I don't know when we will reach. That was like it's arbitrary target. But when I complete my degree, that is already reached. Though I took some longer time because I was doing my PhD in a part-time. But when I completed my thesis, by the time we already reached the plus 1.5 degree. So what about India, where we are standing? So I'm talking about plus 1.5 degree as a global average temperature, which is including both the poles and across all the ocean and land, right? So if you're talking about India, where we are standing in terms of the plus, what is the plus value? So here, like even IMD also confirms that 2024 as the hottest year ever recorded, right? And then IMD also reported that the annual average land surface air temperature during 2024 was plus 0.65 degrees Celsius higher than the longer term average. Okay. So this is the officially announced one that 2024 was the warmest observed for the land area in the Indian continent, that is plus 6.65 degrees Celsius above the long-term average temperature. So that long-term average was 1991 to 2020. If we could have taken the previous, like if we are taking the different long-term, then the value will be much higher. Since we have taken the recent year, from the recent year, like 2020, like 1999, 1 to 2020, that recent 30-year period, then that average, that anomaly is plus 6.65. And this was the hottest year since nationwide record began in 1901. So we have observation from 1901 onwards. And then since then, this is the warmest year in our country. Also, it is mentioned like it's a previous highest record temperature was plus 0.5 degree, 54 degrees Celsius in 2016. So in 2016, it was plus 0.54 degrees Celsius. And whereas in 2024, it is 0.65 degrees Celsius above the normal. Normal means it's a long-term average. So then again, this is the latest update, like WMO chief interviewed that 2024 warming doesn't mean that Paris Agreement breach needs stronger climate action. So like we need more climate action just rather than discouraging ourselves or like we are agreeing or not. Instead of that, like these recommend like we need stronger action. So like now let me show like my results, whatever I want to present. So we know that summer heat waves responsible, summer means like March to June, right? Responsible for the second highest number of deaths after the cyclone. So in India, after the cyclone, the second highest death happened due to the heat waves. And heat waves responsible for more than 20,000 deaths from 1992 to 2015. And it is reported by the NDME. It's a National Disaster Management Authority. Also, a significant increase in heat waves and 146% increase in the probability of heat-related mortality events of more than 100 people. Like more than 100 people, if you are counting as a single event, then that has increased to like more than 146%. And heat waves accounted for about 20% of the mortality from extreme weather events between 2001 to 2014, and it is increased over the period. India has the second largest total exposure of vulnerable people to the heat wave days, and then the trend has been increasing since 2006. So, like under climate change, that IPCC, Intergovernmental Panel on Climate Change, assessment report 6, that's 6 warns of worsening climate impacts on India for extreme events such as rainfall, floods, droughts, heat waves, like variable monsoon and intensified cyclones, and highlighting significant threats to lives, infrastructure, agricultural, and economic exacerbated by global warming. It reinforces the link between the global warming levels and the intensification of extreme events, including heat waves in India. So this was the like a whole summary given by the IPCC AR6 report talking about India and then heat waves. Also, several studies have documented increasing trend in frequency, duration of heat waves in different parts of the India, right? There are so many studies since so many years. This is not my first study which I'm presenting. This is many scientists, many professors already studied upon this. However, these studies use a different methodology on defining heat wave definitions or how they are talking or defining about the heat waves. So, for example, this is the Roshni et al. Published in 2016. Heat wave trends in India, 1961 to 2013. The first figure, the A, shows that the frequency for the total period, and B shows the total duration, and then C shows the maximum duration of maximum length of the duration. So all three shows that it is an increasing trend over the northwest India and partially over the Andhra Pradesh region. And they were using different methodology like excess heat factor, also 90th percentile using the maximum temperature threshold. So, but it is differ from the what operationally used by the IMD. So it raises some scientific questions like are the recently observed heat waves going to change in a warmer climate? And how is that risk of such event likely to change? Right? And will the duration of the longer heat waves increase in a warmer climate? Like already such a past observation, will it increase in the warmer climate in the future? Or will the temperature of the heat waves increase under plus 1.5 degree or plus 2 degree future experiments or scenarios? Or will it become wet heat wave or dry heat wave in the warmer climate projections? So these are all scientific questions arises based on the past observation or the past studies made by other researchers. So I try to answer these scientific questions in my research paper, which is published in 2023. This was the title, like like a climate science to inform adaptation policy, heat waves over India in the 1.5 degree and 2 degree warmer world. It was published in 2023 in the Climatic Change. So you may be knowing that this is the IMD operational criteria for defining the heat waves based on observations. So this is the well-known methodology. You can get it from IMD website also. To declare heat wave, it must reach that T max means temperature maximum anomaly is like 4.5 degrees Celsius to 6.4 degrees Celsius. I hope you people understand what is anomaly, right? Fine. Anomaly is just nothing but it's just a differ from what is the value or today or whatever minus the long-term average, what we are calling normal, right? If from normal, how much it is differ? If it is positive, means it is deviating towards the higher side from the normal. So the anomaly is between like a 4.5 degrees Celsius, 6.4 degrees, that is called heat wave. And if it is more than 6.5 degrees Celsius, then we are calling it a severe heat wave. Or otherwise, the other methodology also called like using just absolute temperature. If it is more than 45 degrees Celsius, we can directly declare it as a heat wave, or severe heat wave means like more than 47 degrees Celsius. But this is applicable only to the station-based observation. But we people, like when we have IMD also issued the gridded data. Station observation is different, gridded data is different. Gridded data means we are representing entire country based on some gridded point, like suppose 1 degree by 1 degree. 1 degree equal means 111 kilometer at the equator. So 111 kilometer latitude and 111 kilometer longitude. That's called 1 degree by 1 degree. So based on some methodologies, these observations are converted into gridded data, so that we can use it for to studying the any of the models, either numerical weather prediction or climate prediction, to compare with the observation. So in point of view, that gridded data has been created. And also, since once we converted to gridded data, that loses some of the peakness because it is because of the smoothing. So this methodology we try to adapt from different research, which is also released by the Indian Institute of Tropical Meteorology, Pune. So they suggested this methodology to identify the heat waves. Like they were using both combination of T max, absolute value, and then T minimum 90th percentile to declare it as a hot day. Also, then to declare the heat wave, it's a combination of like more than 90th percentile. Also, the anomaly should be greater than 3.5 degrees Celsius, or the absolute temperature should be more than 44 degrees Celsius. Similarly, for severe heat wave category, it should be like more than 39 degrees Celsius. Also, it should be more than 99 percentile. Also, the anomaly should be greater than 5.5, or it should be just more than 46 degrees Celsius. So what we studied, that is what the category they projected. Then from that, we isolated hot day only category. It doesn't have heat wave. We just isolated only hot day category. And then heat wave only category. It doesn't have neither hot day nor severe heat wave. It just containing only the heat wave. Similarly, only severe heat wave. So to understand more how these are interlinking or how these are changing the observation. So before that, these two different, like this is IMD's operational practice, operational methodologies to declare heat wave based on station-based observation. And that one was published by the Indian Institute of Tropical Meteorology, Pune, for identifying the heat waves using the gridded data. Then we compared these two, like these two methodology before, because we are adapting to that one. So we want to confirm either these both methodology are confining together. So this is just I took the 3 different stations and then compared with the three different methodology. One is that station data and using the station definition. This one also gridded data, and then using station definition, and then gridded data also using the gridded definition. So what we found that the green line, which is shown across 3 different samples or 3 different locations, it's represent the number of events. The y-axis and x-axis shows that from 1969 onwards annual events. It shows that this definition performance better compared to the this definition on the gridded data, right? So then we are confirming, okay, this methodology is confined for the gridded data. Then after this comparison and improve ourselves are proving that, okay, it is better. So then we are adapting this methodology to understand gridded data and heat waves. So here I shows that 1 second. Yeah. Here it shows that number of heat events is IMD observation 1951 to 2015. Why I stopped 2015? Because that's where I started my career, right? My research 2016 I started. So till before 2015, I took the longest observation. 1951 onwards, we have gridded data. So I took entire data and then splitted whatever I showed in the previous slide, the category, hot day only, heat wave only, severe heat wave only. Then I showed in the column wise, right? Then it shows that the first row shows that annual number of events per year. This value shows that like this entire 51 years, 65 years shows that how it is changing. You can see that more hot days, also heat waves and severe heat wave, and the annual number of events per year also shown in the values, right? And then the lower panel shows that trend in number of events per decade. This is per decade. Per decade also shows that hot day only category shows increasing trend over the Northwest India, and the heat wave category shows increasing trend, like a positive trend over Northwest and Central India. And severe heat wave also shows its increasing trend over Northwest India. Whereas, if you see closely, the number of events per decade over the hot days has decreased over the Central India, whereas it is increased over the heat wave category. Like, let me explain the next figure, will be understanding much better. The similar figure, but here I shows duration. In the previous slide, I shows number of events, but here I'm showing the duration of particular or any of the year average annual mean duration days. The first panel shows, right? Here also we can understand that hot day duration is like since it's a average, it shows nearly like a 1.5 to 2 days. Whereas the heat wave category, the Central India shows that more than 3 to 4 days. Also severe heat wave, like more than 4 days. If I'm taking just trend of this figure, the first figure, trend, all of you know about trend. What is trend? In a school days, we used to study what is trend. Like if we have time series, if you're fitting, then you can like a y equal to mx plus c. That's a simple, that m is the trend, right? So that I'm talking about that m, okay, that m coefficient. So that says like trend in annual duration, like a days per decade. In per decade means 10 year, okay. So in a 10 year, how many days it is increasing? So here the positive colors are shown in the red color, fine, and the negative trends are shown in the blue color, fine. So here a hot day shows that, you can see that hot day shows that decreasing trend over the central India. Central means center of the India, okay. Whereas that why it is decreasing, because this has been migrated to heat wave category. That's why the initially I told that we have taken hot day only category to understand how it is changing. So hot day one, like only hot day only category has been migrated to or upgraded to heat wave category. So hot days only trend is being decreased and heat wave category has been increased, right? But still, if you are wondering, the Northeast India shows decreasing trend in both heat wave only category, also the severe heat wave only category, right? So possible explanation why it is increasing or why it is decreasing here. This is observation of AOD, that's aerosol optical depth. That is the measurement how much aerosols presence in the atmosphere. So that is based on different satellites observation that also published by uh, Pandey et al. So there it shows it's a decreasing trend of aerosol optical depth. Decreasing trend means aerosols is decreasing. So the temperature is increasing. If more aerosols, that will tend to cool down the temperature. Like greenhouse gas tend to increase the temperature, or aerosols or sulfate aerosols, those things will try to cool down the temperature. So already aerosols is less in trend, which means the more temperature is increasing over the northwest India. Whereas the northeast India shows a declining trend, because you can see that this also changes in SO2, that sulfate aerosol, over India between 2005 to 2016, that 10-11 year period. The observation shows like over the northeast India, increasing sulfate aerosol in the observations. Right? Why it is increasing? That may be due to mining work or coal mining, many new mining. It could be one of the reason, or it, but it shows that it is anthropogenic sulfate aerosols increased during this period. So the temperature was cooled down. So like if you want, and if you didn't understand that previous figures, how trend is being calculated or how to understand visually, that was overall picture. Here I'm showing a time series. Say for example, I took this map as the point, different point where different increase or decrease, whatever the trend we have seen in the previous figure, right? Like D is a Chennai, A is a Rajasthan, B is the Bihar, right? So I represented here from 1951 to 2015, that observed period. So y-axis is shows that number of days or mean duration of all events annual, right? Just for that pixel only. This is that pixel, and again the blue line shows that hot day mean duration, and red shows that heat wave mean duration. So I'm just comparing hot day and uh, heat wave. Just duration I plotted every year. Fine. Also, that the dashed line shows that trend line. I'm fitting the trend line, like y equal to mx plus c. That c is that intercept, which also I put a value, right? Once I'm fitting that, you can see that value. Say for example, like A, Rajasthan, it shows both were increasing, hot day also increasing, and heat wave also increasing, which is shown in which is consistent with the previous figures. Whereas in central India, which I mentioned, like hot days decreasing, right? Here you can see that hot day, that blue line is decreasing trend. Visually, you can see that this decreasing trend. How much it is decreasing? Minus 0.22 per decade, right? Whereas heat wave, heat wave duration is increasing, which is shown in the dotted red lines. How much it is increasing? It's a 0.34 per decade. Similar figure, you can see that over again Central India or Chhattisgarh, which is all the figure E, panel E. Here also you can see that decreasing hot day, whereas increasing heat waves. Similar kind of trend you can see over this Telangana also, like a nearly decreasing trend in the heat day, hot hot days, whereas increasing trend in the heat waves over that 1951 to 2015, it's also well represented. So whereas in the big R also, big R in both declining. In big R, we have seen that northeast, it is declining in all the category, like a hot day, heat wave, severe heat wave, right? That also clearly visible. Whereas in Tamil Nadu, southeast, so Tamil Nadu or Chennai region, it both are increased, right? Yeah. So this is at another. We have seen the duration. This is the duration, and this is number of events. Like again, I made it in different way. Like how many events in a year. That also I plotted. There also it is being consistent with the previous results, like increasing or decreasing hot day versus heat wave. So now in the time series also we compared, and in a single figure, like a spatial figure also, we showed the trend. So this is what we understood what is observation, right? So what can we expect in the plus 1.5 degree or 2 degree future? So we use 5 model output from HAPPY. HAPPY is the half a degree additional warming prognosis projected impacts, right? It is based on multi-model ensemble mean from CMIP5. It's a coupled model inter-comparison project phase 5, and its initial condition and boundary condition has been taken. This is defined, I mean, after the limiting, after the 2015 Paris Agreement. Afterward, this project has been initiated. So they made it like a 3 experiment: historical, plus 1.5 degree future, plus 2 degree future. Historical, it was 2006 to 2015. As I mentioned, 2015, why? 2015 only Paris Agreement started. So we were limiting like a last 1 decade. So they were limiting last 1 decade, like a 2006 to 2015, 10 years. Then plus 1.5 degree future, 10 years. We don't know, or they don't know, nobody knows when it will reach that time period, right? So that plus 1.5 degree plus 2 degree time period is arbitrary. There is no like exact year calendar. It's just 10 year, assuming that it will be under plus 1.5 degree or plus 2 degree warmer climate. Also, the aerosols was unchanged across these 2 future scenarios, because we don't know really how it will change between 2 different future projections. So it was kept as whatever changes happened between historical to plus 1.5 degree. So these are all the 5 models contributed to this project, right? All of them having more than 100 ensemble. So maybe I'm talking too much in terms of meteorology or climatology. If you're not understanding, please tell me. So ensemble means, see, like if I'm saying one model means it's a set of equations, right? Then we are projecting the climate. Just a single model, I'm saying, okay, like tomorrow there will be rain, or tomorrow there will be temperature, hot or cold. So if it is called, it is called single deterministic model. Instead of that, if I'm running same model with different initial condition, or some changes, some small perturbation we are adding, then I can generate 100 different combination or 1,000 different combination. So what will happen if I'm getting 1,000 different combination? So I can get the probability. Instead of saying like what will be the temperature, some climate change, then I'll get the probability, because I'm having 1,000 combinations or more than 1,000 combination. From that, out of 1,000, like how many are giving the whatever the temperature I'm saying. Suppose 500 is coming, then I can say 50% probability to reach that kind of threshold, right? So this is the probability. To get the probability, we need ensembles. Ensemble means like same deterministic model, but changing some combination of initial condition or boundary condition, and then generating different outputs. So, sorry. Aerosols are unchanged between plus 1.5 degree and plus 2 degree.
So what do you mean by aerosol?
So that is what I mentioned. Aerosols is the playing role for reduction of temperature. SO2, sulfate aerosol, which I showed in the Bihar region or the northeast region, it is showing decreased heat waves because of the aerosols. Aerosols means it's a very finite particle. You can say just dust, assume like a dust in our, like at a 10-meter height, suppose, like where we are standing or where we are traveling in the car height. If more aerosols are there, what will happen? Incoming solar radiation, like where from the sun, we are receiving the solar radiation that is having tended to distract or refract. Okay, so the temperature will not heat the surface of the earth. It will be reflected or refracted. So finally, the earth temperature is reduced because it is not reaching, it is just in the atmosphere or going back to the space itself. So due to that, the temperature is decreased. So that is the property of aerosols. Whereas CO2 tend to hold the temperature in the atmosphere itself and then giving return back to the surface. So that will result in the increasing temperature. So that is two different property of two different gas. Yes, exactly. Because a black carbon, that also another aerosol that will tend to increase the temperature. So it's a purely property of aerosols. But most of the aerosols, like suppose a sulfate is the major one of the aerosols that will tend to cool down the temperature. Some other aerosols tend to do the increase in the temperature. So it is having both property.
Yes, of mining.
Sorry?
Due to mining it happens. Aerosol.
Yes, yes. Yes, because we don't know what will happen between plus 1.5 degree and 2 degree. But historical to plus 1.5 degree, already it has been projected. That aerosol changes has been applied in the model. But plus 1.5 degree to plus 2 degree, we don't know exactly how we human people will introduce aerosols, because this itself, that time it was arbitrary. We don't know when it will change. That was under the assumption of 2050 it will reach, or end of late 2050 it will reach. Nobody guessed or that it will reach in the next less than a decade, right? But now if you are doing a assessment, maybe we can do better the changes, because we already reached the plus 1.5. We know how much we are loaded aerosols, right? This is 10 years before how it was initiated, the project.
So you are keeping the aerosol concentration fixed for these two simulations.
Yeah. Yes, yes. So though, like we so far understand the what is the observed data, and straight away we started with the model. So before model has its own biasness, right? So we need to check the whether it is consistent with the observation or IMD observation, what we call. If it is consistent in the historical period, then I can believe the future, right? So as I mentioned, like it is having three experiment: historical, plus 1.5 degree future, plus 2 degree future, right? What is my stand in the model in the historical? Historical means what? Nothing. It's just we are recreating the history in the model. Because in 2015 or 16, this project has been created. So we all know what was observation from 2006 to 2015 by loading those observation to the model and then recreating the historical data. If I'm able to produce that correctly, then my future also I can believe, right? But model has its own biasness. So first we are checking what is the bias. Bias means just error, or it has its own tendency of either warming, more warming, or less warming. That bias would be there. So we are verifying those models. It's just taking the mean, like maximum temperature mean error. It gives like error, like you can see like month wise. I put it in the column March to August, and rows represent different models. Those 5 models. it is giving like you can see like both the extremes. Bias is like more than 5 degrees Celsius, or even like the negative bias minus more than 5 degrees Celsius also. So, but we utilized empirical quantile mapping method. So I'm not discussing much about mathematics. I'm saying that after the bias correction, the bias is reduced. You can see the scale. The maximum bias is like a 0.5 degrees Celsius positive, and then the negative minus 0.5 degrees Celsius. So there are methodology available in the community. So we used a better, identified a better method. So the bias is mostly reduced like within like a 0.2 to minus 0.22. So error is in the historical just a 0.2. So with that confident, now the same correction has been applied to the future also. So whatever the correction we are doing historical versus observation, that correction factor we are applying to the future from historical to plus 1.5 degree, then again historical to plus 2 degree. So now we can rely on those outputs. Fine. So now again I'm comparing how the model wise, observation wise, hot day and heat wave, severe heat wave category, the row wise for the 100 ensemble members. I hope you understand what is ensemble. So each model we took 100 ensemble for the consistency. Here you can see that like the first row shows observation, and the next 5 columns shows 5 different models. You can see that a hot day gives similar kind of number of events, right? Similarly for heat wave, similarly for the severe heat wave, like it is well represented in the historical, most of the cases, mostly. And this is called Taylor diagram. Maybe some of you know or may not be knowing. So this is just to represent like here it is having three information is having like a correlation. This is shows correlation, and here it shows standard deviation, and inside it shows that RMS, a root mean square error. Nothing is just like these are the 5 models, and this is observation. Closer to the observation, it's better. I'm just explaining in this way. So it gives like correlation. All of you know about correlation coefficient, right? Fine. So it gives like if it is more positive 1, it's a good, or closer to the 1, it is good. That much you can understand. So it gives the hot day, heat wave, severe heat wave, or more than like 0.95 correlation. So this is especially we took and over that 100 ensembles compared with the single ensemble or single relation of observation, and then it gives better results. So which means we are able to predict like, not predict, like we are able to assess that it is giving more than 0.95 or 99 or 95 correlation coefficients. So with this statistical confident, we are now going to study the future. So this is like a future, like now, as I mentioned, like the purpose of bringing the ensemble is one of the purposes to get in terms of probability. So here I'm showing probability of heat event days. Okay, here using 500 ensemble members, because 5 models, all of them produce more than 100, but I limited to 100 to be consistent. And then 10 years. So future is having 10 years, right? So here like four different months, April to July, and then historical plus 1.5 degree and plus 2 degree future shown in the 3 different rows. So what you understand from here? Like this is historical, this is my historical. Okay. Say for example, May month we are taking, or April month we are taking. Anything you can take it. So what is the value? Value is like a 0.1, right? Or like that the yellow color is showing that 0.1. In the April month, it shows the plus 1.5 degrees. The central India is not much change, whereas in future, it shows like a more than 0.25. The probability is increased. To get the categories, either it could be heat wave or severe heat wave, that category, that where that inner circle. Or in the May month, you can see like let's take example in the May month. May month historical shows like a 0.3 at its rotated pixels over the central India, whereas in plus 1.5 degree future we can see that more elongated probability, like more than 0.35 or 0.4 probability at the central India in the plus 1.5 degree future, which means in that central India to get a heat wave or severe heat wave warnings or category, the higher probability is there, and much higher in plus 2 degree warmer world. The last row, right? And interestingly, the June month or July month, you can still see that higher increasing probability in the plus 1.5 degree future, also in the plus 2 degree future. So why I'm concerned about June? Because it's a monsoon, right? Monsoon starts in the June, and it is having June to June, July, August, September, southwest monsoon. So what happens when mixing of temperature and humidity? You will feel like more temperature. That's called heat index. That's a more different way of calling. But the thing is, if you're adding, the water is having more heating capacity, it can hold more heating. Okay. So when moisture is there at our, when we are walking outside, if more moisture is there, you will feel like more temperature. The feeling temperature will be higher. Yes. So that is the worrisome actually. Okay, we are adapted to summer. Okay, I know this is summer month. May month is summer. Okay, I'm happy because I know this is summer. But when you feel like, okay, this is rainy season, but you will feel like more temperature, more warmer than the actually what you felt it in the May month. So, but that time we will not be prepared because we are prepared for rainy, but you will feel like more warmer than the May month. So that kind of worrisome will be there in future.
The March month why was not considered.
I just limited that. I could have studied that also. I studied, but I just limited. It was not showing that much. So here I'm showing that different results. Like what is the consecutive days event and its probability. Suppose I'm taking only 3 consecutive days. I'm understanding it's a heat day, hot day, or severe heat wave, or heat wave category. Or if it is if it is just 5 consecutive days, or 7 consecutive days, or 9 consecutive days. If I'm identifying one consecutive days means like a day 1, day 2, day 3, all 3 days having heat wave or severe heat wave. Or likewise, all 5 days is having a heat wave or severe heat wave category. Then we are calculating the similarly 500 ensemble members. So 1500 ensemble members has been utilized in this figure to produce that figure. It gives like what is the probability. So the warmer color shows in the red color shows that a higher probability, right? Here also you can see that the very higher probability when in the future plus 1.5 degree and plus 2 degree warmer world, even across like
The interior, the different doesn't matter. Total clearly. Because it's the same in all. Percentage.
no, if you see that there are changes. Suppose here, this coastal in the 9 days, like that is the very rarest event. But if you see that in the future, it is giving higher probability. So in the coastal, actually the definition wise, IMD definition wise, coastal threshold is different. But we just use that IITM Pune definition, which involves all the category in a single definition. But however, it shows that it is increasing probability in the future. If you see the north, like especially Chennai or Andhra Pradesh region, that's a coastal region, it is getting increased. The next figure will explain better. Okay, the probability is very less. It is like since this is 500 ensembles, okay, out of 500, it is like to get like a e to the power of -5, it is very less probability. To highlight the other event, I kept in gray. There could be possibility also. but it is like, suppose 1 in 500 or 2 in 500. But we are discussing about like a 400 out of 500 or 450 out of 500. So when I'm discussing about that, so I'm least bother about those things to neglect.
Also, the absolute number, the probability number 0.003, that's a very low probability.
Just because we used a 500 ensemble. Suppose if I'm using only 100 ensemble, then you just multiply this with 5, then you'll get a higher probability. Okay, so it's all a relative frequency or relative probability with respect to the number of relative ensembles. To you ask the right question. To solve this problem only, the next slide will explain. So what we did, we just taken the ratio, probability ratio. So we, in the previous figure, I showed that the historical probability, also the plus 1.5 degree future probability. So if I'm taking ratio, it gives how much time it is like how much time it is increased, or what changes in terms of times, like how rapidly it is changes. So the first row shows that the ratio of probability between plus 1.5 degree future and historical, okay, for different consecutive days. Similarly, for only for the heat wave or severe heat wave category during March to August for 10 years. So this is not only for 500 ensemble, all of them having 10 year of, okay. So 10 year also for those 180 days, March to August, that's 60 days. So 180 days into 10 year into 500 ensembles. So those many combinations of time series we have, out of that we have taken probability and then its ratio. So here it gives, like suppose for like let's consider 5 consecutive days, the central India shows that it is increased up to like 2 to 5 times, right? Like if it is in the future plus 2 degree to compare to historical, the ratio that also increased like more than 2 to 5 times. So that is what I mentioned, like event lasting for 3 to 5 days or 2 to 10 times higher, right? Like even that more than 5 pixels also you can see that like it is 2 to 10 times higher for the 3 to 5 consecutive days event. But if you're considering 9 consecutive days, like longer period, like 7 to 9 consecutive days, that you can see that like even 10 to 30 times higher. That the greater color of red color shows that many pixels shows that like 10 to 30 times higher for the longer duration when we compare to historical versus plus 1.5 degree, also plus 2 degree future. Also that new event, suppose how we are taking ratio, probability of future and probability of historical. So something happened or new thing happened in the future vulnerable, which was not observed in the historical. So I have to divide by 0. If I'm dividing anything by 0, it is infinity, okay, because it was not observed. Doesn't mean that I should ignore in the future. So in future world, it is showing some new heat wave category or new heat wave or severe heat wave scenario, which was not observed in the historical. So that is shown in this purple color. So these, since it's an infinity, that ratio here it's shown in the purple color, which are all new zones of heat wave or severe heat wave category, which was not observed in the historical or in the observed event period. So what the conclusion? The major conclusions will get more new heat wave zones, right? Especially like the southern peninsula, these regions for the 9 consecutive days. Like even for the 5 consecutive days, you can see that new heat wave zones are likely to happen. Suppose if you're talking about that blue color is less than 1, right? The probability ratio, either if in future if it is reducing compared to historical, then that blue color will come. But nowhere the blue color is seen. We are seeing that either the warmer color, that yellow to red, or the purple, which is infinity, which was not observed in the historical, but in future projection it is seen.
So, are there any specific reasons for these zones? Historical reasons, any geographical reasons or climatic?
This is, we are talking about climate only. Climate change, under the climate change, it's just here we did not consider much about that geography, how it is represented, or what is the land use, land cover. But if you are talking about localized one, then we need to talk about heat island, where like more industrial or more concrete stuff are there, then that will make a localized heat event. But when we are talking in terms of climate projection, so it's just coming from the global increase. So it has to increase. So where you will increase, like already in the we have seen this red page already we observed in the historical. So where it will come, the new zone is coming in the corners. It cannot just go somewhere differently, because suppose if you are taking this zone, that heat is spreading across the neighborhood in the future scenarios. But in the historical, it was not up to that reaching the definition or reaching the threshold. So it was not reaching in the historical, but in the future, it is very easy to reach or spreading the different or expanding. You can say like it is expanding, which was not observed in the historical period or that time zone.
Yes, but that the heat waves may be occurred rarely. So why you have taken the data July and August? Is there any reason?
No, March to August, right?
But the website is saying that it's from March to June. And
Yes.
rarely in July.
Yes.
That is data.
Yes.
Then why-
Yeah, that is IMD definition, just talking about in terms of weather.
It talks like India heat waves occur mainly from to June. It is some rare cases even in July. The month of heat wave over India is
Yes, what I'm saying is IMD is talking about weather. Weather means it is just day-to-day changes. It is general practice. We still observing like March to June, rarely in July. But we are talking in terms of climate. Okay. In future scenarios, we don't know what could be the future changes. So if I'm not accounting in August, right? August is what? It is already the peak of monsoon. If I'm not accounting August, then like we are losing some of the information in future. If we are not studying the accounting for August also, then it could be heat wave also that time.
Actually, your previous data shows that. That shows July.
Yes.
why it has been the other data.
No, the question is like, it's just choice of questions. What question I'm asking to myself? What happens if I'm choosing August? What happens if I'm choosing September? In 2023, even in September, October also, heat wave was observed in the over Bihar region. Right? It was observed.
More idea of it.
Yes, it's just like we are trying to inform to the climate policy holders, like how we have to be prepared. So I'm just accounted for different results for different extending period. So now just stop me if you are getting bored, okay? So here I'm trying to study like just a few more results. Let me show you. So here that I shown in the table like year and mortality. It's observed mortality by the NDMA. It's a National Disaster Management Authority. From 2006 to 2015, we have identified 6 different years where there was more than 1,000 mortality. Right? So we identified those 6 years and shown in as observation, which was heat wave or severe heat wave category. Okay. Then also we shown it here it as a duration of large event. We just try to study one large event. It could be multiple event, but we try to study either it is spatially, also temporally, it is a single large event. Then we identified here, it shows a duration. Like here I show that color bar shows different duration in terms of days, right? Say for example, in 2009, where it's more than 1,000 mortality happened, that is the greatest or large event happened. Like the some pixels shows more than 9 days also. Similarly, for 2010, 12, 13, 14, 15 shows different pattern or different durations as a single large event. So why this I'm studying? Because these large event caused more than 1,000 mortality. Okay, mortality means like the human died because of the heat waves. So if I'm studying this pattern likely to change in future, then like we'll be prepared or will be informed how it will be changing or how much frequency likely to occur, these kind of scenarios again, right? So like how this will change in future, just like since it's 1,000 mortality happened, this pattern, spatial and temporal large pattern. So we are just studying in future. Like this pattern again, I'm just showing here in terms of what was the starting date of the such a large event. Like some of the year started in May month, May 6. Some of them, like 2014, it is started even in June 15th. The red color shows in 2014, such a large pattern started in June also. So it doesn't mean that always May month. If something is starting in June month, then like a five days, or it could be what was the duration? Like here, the duration is like nearly 7 days or 8 days. The 2014, that the color shows 6 to 7 days. So when it is starting in June 15th, which means till June 30th or nearly 30th, it will long last that such a long heat wave, right? So as I mentioned repeatedly, June is the monsoon time. Like they'll get more heat index or more, the feeling temperature is very high. So here, here I shows that the frequency, duration frequency, how it's likely to change in the future. Like same those pattern of 2009, 10, 12, 13, 14, 15, where such a large event spatially and temporally happened. So here we are comparing with the frequency. The x-axis shows the duration in terms of days. So we are comparing with the IMD observation that is shown in the asterisk symbol or star symbol, and historical shows that a brown circle, right? And the plus 1.5 degrees shows in the blue and plus 2 degrees shows in the red. See, this is simple figure. We try to simplify this. So, you forget about the frequency, like a frequency. Suppose if I'm taking frequency at any given point, let's say, for example, like I'm taking the 2015 event. 2015 event to get 100 frequency, okay, and for 10 days. If I'm considering this historical, here if I'm taking, suppose this 15 days event. 15 days event is giving frequency as a 10. But for the same 10, okay, if I'm considering plus 1.5 degree, that duration is like nearly 25, right? And for the future plus 2 degree, that will be like more than 29 duration, right? But if I'm sticking to any particular duration, the frequency also likely to change. Say for example, say I'm fixing like 15 degree, so 15 days. For the historical, frequency is 10, whereas and plus 1.5 degree future, the frequency is increasing like 100. And similarly, plus 2 degree, it is increasing 200, right? This is little complicated figure, but we try to simplify it in terms of this figure. This is a little, I mean, more complicated figure. It's a three-dimensional figure, three-dimensional or four-dimensional information we try to put together. This is joint exceedance frequency. So two events are joining together. One is maximum temperature, other one is duration. X-axis shows the maximum temperature, Y-axis shows the duration. So we are joining together and then calculating its frequency. For the heat wave or severe heat wave category, again March to August, 10 years in each category. The first row shows observation for those identified 6 pattern here. I hope you understand what is joint. It's like a joint probability, and instead of probability, we are showing frequency. So when the duration, the y-axis shows like more than, say, for example, more than 8 consecutive days to reach 40. Also, the x-axis shows like a 40 degrees Celsius or 48 degrees Celsius, right? If you are picking such a any event from observation to historical, that frequency is increasing because historical having 500 ensembles, right? More ensembles, so it giving more frequency. However, when we are comparing historical to plus 1.5 degree, spatially you can see that all over the pattern is increasing. Also plus 1.5 to plus 2 degree, again it is increasing. So what we are trying to conclude here is that for the heat wave or severe heat wave events for different duration and its corresponding daily maximum temperature over grid cells, like for those large area, all the grid cells only counted, and duration is calculated as a consecutive days. Like that the y-axis shows a consecutive days. Like even you can see that like some of them reach 44 days also in future. Why I'm showing 44 everywhere? This gray shows that it's a 0. There is no such a event. Why we kept a 44 year means this 2014 kind of pattern in plus 2 degree future, it shows that such a very high, like though it is low to reach that 44 days with a 40 degree Celsius temperature, that frequency is very less, but still we want to project it out of 500 ensembles. Sorry, 1000, it is 1500 ensembles. Right, but practically speaking, suppose if you are taking 4 days, 4 consecutive days, what is the probability to reach 44 degrees Celsius? So in 4 consecutive days, we are reaching for 44 degrees Celsius. That is very much high in the frequency compared to the historical or plus 1.5 degree future. This is just for any, if you're taking any one of the cases. And this is like, I think this is my last concluding figures. Here what we represent, this is relative frequency. That is frequency for joint exceedant frequency. Here it is relative frequency for the large event area fraction. Here x-axis shows the area fraction rather than temperature, right? So y-axis again shows the duration. That area, whatever I showed in the observation, 6 different pattern, either how much area is covering out of those pixels. If it is reaching 100, which means that entire area will be covered, whatever observed. So say for example, if you take any day, any of the event, 2009 or 2015, in the historical, to reach 100% area coverage, right? That duration is like, say for example, 36 days or 16 days, if you're taking anything. But if you're comparing with the plus 1.5 degree, it is getting increased. That relative frequency is increased compared to the historical. Similarly, for the plus 2 degree, it is even gone the peak, like more than 0.35 relative frequency. So the main conclusion is that it is in the future to reach that 100% area coverage. It is very high in the frequency compared to the historical. Say for what I'm explaining here, the higher relative frequency at a longer duration or the larger event area fraction, like 70 to 100%, nearly 3 folds greater, 3 times higher in the plus 1.5 degree and 5 times or 5-fold higher in the plus 2 degree future compared to the historical simulation, right? So to reach such an event, like covering 70 to 100% area coverage in plus 1.5 degree, it is nearly 3 times higher, and plus 2 degree, 5 times higher. Also, the smaller relative, like less than 0.1, between 30 to 70%, which is this color, this light pink color, shows that majorly covering 30 to 70% of the area fraction. But this is both in the future, it is remain, but still there is some variation is there. So, like, let me put together all the whatever I discussed so far. So, from in India, 1951 to 2015, most regions shows a decrease in hot days duration, except for the northwest India and southeast India, where both number and duration of heat days have increased. The decreasing trend in the mean duration or the number of hot day events is explained by an increase in the mean duration and number of heat event days. Like hot day decreased because it is migrated to or upgraded to the heat wave category. Okay, in the most of the central region, right? Then in the plus 1.5 degree and plus 2 degree future climate, frequency, also the duration, such events over India increases in comparison to historical. Historical period was 2006 to 2015. Also, the shorter events like 3 to 5 days or 2 to 10 times more likely. Also, the longer event like 7 to 9 days are increased by 10 to 30 times. Also, probability of heat wave or severe heat wave events in June, July is increased, and it is implying the added risk to the higher moisture, that is higher heat index, right? There will be new regions which will be experienced or prone to the heat waves in the future warmer world, which was not seen in the historical. So that also like for the longer duration, that also nearly making troublesome in future. Also the higher relative frequency at longer duration and a larger event area fraction, like 70 to 100% area coverage, nearly threefold higher in the plus 1.5 degree and 5 times higher the plus 2 degree compared to the historical. Finally, while the highest temperature, this is the one of the conclusion, like while the highest temperature in the heat waves may not increase, okay, it will be like limited to 47 or 48 degrees Celsius only. So in future scenarios, it will, as I shown that figures, the y-axis was limited to 48 only. Even that special figure as also the scatter plot at 1 degree by 1 degree grid cell, but its duration and area is increased. So that is the major concern. So 47, 48 doesn't matter, but the longer the duration is the matter. Like if for longer days, we'll be experiencing 47 degrees Celsius is more danger rather than single day like a 50 degrees Celsius. That also okay, but we have to understand like more longer days, we have to adapt to that kind of weather condition. So in terms of that is scientific conclusion. What about policy? Like we required maybe a high resolution climate data to develop detailed climate knowledge to guide our adaptation policies using existing tools. We need more climate data. Also to boost the climate science in a vulnerable region, like it can give the strength and climate research in developing countries like our country facing severe impacts like heat waves. And also we need to close the gap between the science and adaptation policy, address of the lacking the actionable climate science as a critical, like funding is one of the gap, right, through the global initiatives. And also build a local capacity, like empowering local efforts to generate and use climate knowledge for effective adaptation. Like notably NDME, it's a National Disaster Management Authority, and SDME, just State Disaster Management Authority. They are taking heat action plans since 2015 very effectively across the country, even at the city level, village level, and much actively. And it implies reduction in the mortality due to the heat waves in the recent years, right? But finally, like both global and regional policies matter. We should focus on both how globally the policy is playing, regionally policy is playing. Those things are matters. So I would like to thank my IIT Delhi and whoever made this data set openly available. That's why we are able to study this, right? So still, if you are curious about heat waves, the future world, like how it will change, I can just give a hint of my unpublished results. This is like in plus 1.5 degree and 2 degree, future climate can trigger more early heat events, more early heat events over the northwest India through teleconnection. Teleconnection means which has happened over somewhere else that is causing heat wave condition over here. Okay, but overall seasonal, the number of heat events, it is like it is unchanged its frequency. The seasonal is not changing, but it is happening early. So that is a new conclusion which we are drawing under the plus 1.5 degree and 2 degree rule, which I'm working on to publish it. So maybe once I publish again, I can come and talk about that. Is more complicated to discuss because I'll be talking about many teleconnections.
Just drawing a
Yeah, let us get into the question and answer. So before that, we'd like to thank the speaker, Arulalan. Very wonderful. One moment, please. Recently, the
Thank you,
book written by Dr. Parasir V. Murugan is available here.
Oh, thank you, sir.
Yes, now we will go into the question and answer session. Before that, no, I invite audience to register feedback. No, share a QR code. Just scan the QR code. And here. There are two things. One is now you are entering your communicate with the future. All our future events will be connected. Posters or anything will be. The second one is the membership foundation. Both are okay. Feedback. I invite you to become a similar side as I told you that we have activities to work in the side. We are working with 6 different areas. If you are interested in writing science writing, you can write. And you can do a couple of magazines, only some Tamil, other one is in English. And we also have people who are interested in studying the development and environment. They can also contribute. And some people are interested in science communication. They will also contribute. And who are interested in gender equality, more women in science, so they can also participate in science. So because of the kind of things, you can choose your activity.
I think I took longer than like nearly 1.5 hours.
Yeah.
I used to speak this in 10 minutes at like our scale, like a conference, because all the audience are already like higher than my level. They used to cross question like anything. We used to complete in 10 minutes, but here I had to explain because of the interdisciplinary. I hope I explained better, but this is my first.
Popular.
Maybe in the next one, I have to shorten many things. I'll just stick to time that time.
Yeah, let me start with the question. It's not related to very area. Although it is connected with climate change, you said that aerosol is reducing the temperature. Why can't we pump the aerosol if it is not harming the human beings, right?
No. It is reduced. Only one aerosol is reducing. Okay. I also repeated like it is increasing also, like a black carbon that will try to increase the.
Okay, can you spread in the surface area of the
that is
sea?
harmful
means
to
that-
health. Sulfate aerosol is harmful to health.
That's
We
fine.
cannot just load it.
Temperature rise, I think it is okay. Other environmental conditions.
No, it is one of the cancer agent Okay, it's very, very harmful to the, like, we are thinking like ozone is a very good agent. But if it is coming to the ground, the troposphere, that is harmful to the health. Okay. It has to be where it is already placed.
No, one thing I find that this the scenario of 1.5 degree, 2 degree is totally different from the scenario of the previous years, right?
Yes.
So ultimately, you need to reduce the temperature so that you will not get into the trap of getting into the heat waves and hot days, right?
Yes.
So to do that, one is you have to reduce the carbon emission, all those things. That's another thing. But other thing, can you do something in the surface of the sea so that you can reduce the overall temperature of the air? Is there any
No. Actually, my another result is there. That was my MTech study, which still we are pursuing that. What we studied in surface, like a sea surface temperature, we used to say that SST, or the Indian Ocean, it's already increased, and that also due to the human influence, or the 100-year data, that we have 100-year observed data. So that there also we study like it is like a GHG is increased and air source is decreased. Finally, it is increased. So one is like increasing, other one is decreasing, but the net result is still increasing. So we cannot decrease the ocean temperature and all. It is
that's
ocean is the main earth of temperature is held by the ocean, because water is having more holding capacity of temperature.
correct?
It's already reaching its
Maximum.
we already spoiled that earth, so we have to do only thing is further not increase the damage or try to suppress it.
Good afternoon, sir. Thank you so much. Sir, what were the challenges faced by IMD in monitoring the path of a Fengel? Because in the last year during the monsoon, in the morning they were saying that the system will not become into a cyclone. In the afternoon they were saying it is less likely to become a cyclone. In the evening they were saying it is not possible to become a cyclone. When we woke up the next day, there was a news, it has turned into a cyclone. And I was using ECMW model to track this. Even before the 15 days before this progress of that particular system in the Bay of Bengal, it was less likely to become into a depression. It was just crossing the Gulf near Sri Lanka. And in the next 7 days, I was able to see the movement, the northwest movement, and it is coming near the like the Nagapattinam region, and it was moving along the coast and becoming the Fengel cyclone. So, and then there was a news. ISRO is coming into the discussion and like trying to monitor the track, something like track the trajectory of the cyclone. So, what were the challenges? The first question: what can we expect in the future? And I do not know whether this is new or just new to me. In the past 3 years, I see that there are two cyclones, or at least two systems, one in the Arabian Sea and another in the Bay of Bengal. I have seen it, but it was not. I think it was not there before 10 years. Of course, the system formed in the Bay of Bengal will cross through the land, and sometimes when they reach Arabian Sea, again it will become into a system, and then will move to the westward, sometimes Oman and other regions. But this time, and last year and even before last year, I saw two systems simultaneously in the Bay and the Sea. The second thing, when this is possible, with this prediction, the heat waves, some new regions will be prone to the change, and the intensity, I mean the heat wave the duration will increase, the frequency will increase. What will happen to the power grids? Because they depend on the ambient temperature also. So more the atmosphere or the ambient temperature, the power systems will be affected. Do we have a proper planning that you, like the scientists from these institutes, inform the Ministry of Energy that in future there will be a problem like this? Because we rely on 70% of thermal power plants. Though we are having transition towards renewable energy, still we are relying more on coal and we have to use the thermal power plants to burn coal and produce and electricity. But this temperature increment will definitely affect the energy power grids. So the second question, sir. So first one, what were the challenges faced during the Fengel cyclone period? The second one is there any proper way of addressing this issue related to the increment in temperature with the energy power grids?
Okay.
Thank you, sir.
Yeah, fine. So, shall I answer the two questions? So, we are not just using single model, we are using multiple model operationally, like more than 9 models to predict the cyclone tracks. So, and then we are also doing the value addition, right? Numerical weather model, we are using 9 or 10 models, and then we are just coming to the consensus. Also, the value addition is the playing matter. So based on the current observation where that cyclone or depression is location, based on that, the value addition being added, and then coming to the conclusion either we are go with the model or giving the over warning or under warning. So due to that, you might have seen that sometimes like withdrawing that like cyclone, but again we are seeing that increment. But that this in the last 4 years, the Fengal one was the, I would say, like this kind of scenario happened, like because model was keep on showing that it was a slow movement. It was intensifying, then it was like decaying, but again intensifying. So this need to be studied. So like I'm also part of the work predicting, also studying. So I cannot comment immediately why different models gives different results in the slow movement. That many things like from ocean observatory also we need to think how was the ocean condition, either it was a land breeze, sea breeze, those things also we have to take into account. Then we have to come up to the scientific conclusion why it has happened. So that we are already working on it. The detailed paper will come.
Is it due to lack of data or?
No. It's not about letter. So models are able to predict. All models were showing like similar kind of behavior. We able to predict the track exactly like 5 days before. There was no challenge in track. Only thing is the intensification. So we are trying to work on bringing the better intensification. So that will give only the intensification is the problem. Otherwise, the last 10 years or in the last, especially last 4 years, we are able to give exactly the track well in advance and with the pinpoint land location. Also in the both Bay of Bengal and Arabian Sea, the simultaneous occurrence of cyclone, this is not the new. It was already happened in the past also. This is just for the information. And regarding the power grid, like we are, IMD is like giving the warning in terms of weather. So we cannot give the command or recommendation to the other ministry. So there are policymakers already is doing this kind of work. They like NDME, like National Disaster Management Authority, they used to call for this kind of policymakers. They used to interact with the how like one will affect the other. So that is their job that they are doing it. Like apart from this is not my IMD work, whatever I showed, because I studied in IIT Delhi as a part-time PhD student. This is totally different work before I joined IMD. Okay, so this is not the representing the IMD results. Still, I'm making that. So this is just to like as a individual researcher. This is what I studied. This is what I used. This is what then like whoever studying the climate adaptation policy makers, they may be studying all these papers. Then they will take the necessary actions. How one will impact the other. So they will try to take the necessary actions.
But in case of tropical cyclones, it seems that it's not that much predictable. Is it
Yes. Yes, exactly. So tropical cyclone is a challenge because, like, if it is subtropical or extratropical, there, whatever you call a hurricane or whatever we call, that is that will not change rapidly. But in tropical, like where entire belt is tropical belt is there the cyclones tend to change rapidly within a 6 hours. As he pointed out that within 6 hours or 3 hours, intensification it may decay or again rapid intensification can happen. So in observation itself, like within like it will become the intensification of cyclone may likely to change within rapidly. So the predictability is challenge in tropical, but still that trajectory path we are able to like make it exactly well advanced prediction, like even 5 days before, nearly like a 25-kilometer error only. But the intensity still we are working on it. The value addition playing major role. So we always give some higher warning to reduce the uh, casualty. But however, that is not giving any negative impact in terms of higher warning. So always we used to give higher warning to reduce the any life threat. Value addition, like that is what experience playing matter. So our officials having like a more than 10 years or 20 years experience on cyclone, they know how things are happening, just not blindly believing model alone. So they know, like I'm just a new kid joined in this institute, just doing the new stuff. But previously, like 20 years experience or having many scientists, they know how this will impact. So that is what value addition. They will correct the model error. If one model may go wrong, so we may remove it dynamically.
The part of the science side.
Yes, yes,
Taking it up with practice.
yes. So finally, we are giving only one output to the public. But when I'm producing, my result will not come because whatever like me, whoever working on cyclone, that result will never publish to the public because that may go wrong. That is where value addition playing major role, and they will announce a single results. So that is what like during cyclone IMDs used to give the press release. Press release means that's the final track at that time. What is the projection?
So recently there was a report in the newspaper saying that
Excuse me. Yeah, without this, yeah, let them finish.
So, hello, sir. So it was a much insightful session. I have a few questions. The first thing is, as I could see, climate change is a global problem. So India isn't specific to climate change, but the thing is, what if, like certain countries like Canada or stuff like that, they benefit from climate change, as I could see, because they have colder climate, and when it warms, it makes them viable for agriculture and stuff like that. So how we could derive a global action? That's my first question. And if we aren't acting on climate change, is it like the carbon capture, utilization, storage the only solution for that? And the third question is, uh, as I could see in a lot of media reports, they say that if we don't act in the next few years or something like that, climate change, effects of climate change would be irreversible. So what do they mean by that?
So let me start with the third question. Like
Okay.
the effect of climate change is irreversible. Like as we discussed so far, once we reach to like plus 1.5 degree, 10 years before when we started this community started this project, like 2015, like we at that time nobody knows when the earth will reach plus 1.5 degree compared to the pre-industrial. It was just really like some arbitrary year. Someday we will reach. We were trying to limit the global earth temperature up to that. But you see, in 2024, it's just less than 9 years. Within 9 years, it's already reached. So irreversible means we cannot reduce the temperature. How you can reduce the temperature? We are already industrialized. We made it. You cannot take away the industrialized immediately, or it is not possible. Industrial means like, say, for aeroplanes, ships or all the power supply. Like this is everything industrialized, right? We cannot take away at any cost. So already we reach temperature, so it cannot be reduced. So how? So we are trying to limit it. Okay, let us keep some limitation. Then the earth will still, people will try to adapt to that climate. So that is why that government or intergovernment panel limited, like, okay, let us try to keep it limit plus 1.5 degree and then maximum by plus 2 degree. If you are not doing limitation, WMO mentioned that end of this century we will reach 3 to 5 degrees Celsius compared to the pre-industrial condition. They were saying like end of the century, or if you are not limiting, like, then it may happen the next 1 decade also, right? Maybe within a 10 years or 20 years, we may reach suddenly like plus 3 degree. I'll be talking about plus 3 degree discuss instead of 2, right?
And when you spoke, you said that in 2024 it has reached 1.5 degrees Celsius.
Yes.
And somewhere in the IPCC report or something like that, I heard that it was like if we wanted to limit global warming by 1.5 degrees Celsius, we need to invest this much amount of money. And if we wanted to limit it by 2 degrees Celsius, we need to limit this much amount of money. But as per your presentation, it's like we have already reached 1.5 degrees Celsius. Is it true, sir, or like?
Yes. That report is AR6, right?
Yeah.
Or AR5 or AR6. In both, they were discussing, finally, their conclusion is the money, right? How you can reduce it. Either one country has to put more money so that like more benefit in terms of say, for example, if you're utilizing more solar panel, right? But we may be talking about like suppose electrical bike instead of normal bike. So the normal bike increasing the pollutions and more aerosols. But you know that it producing the electricity battery, the production of battery consumes more. It is releasing more CO2 than the normal petrol one. Okay, so in one way, one production is benefit to the climate. On in some other way, some angle, it may be in bad way. Similarly, for production of a solar panel also you have to like you cannot just, it is just not like readily available, right? We have to heat it and we have to melt that. So for that, how heat will come? Some CO2 is we are being generating, right? So somewhere some CO2 being generated and then we are replacing in the name of like solar panel. I'm just giving some random examples. Okay. So in terms of money, like they are assessing how much money one country or globally has to invest so that it can be limited to reach plus 1.5 or 2 degree. What was the other question?
The other question was like, as I could see, the global efforts to combat climate change isn't going on track. So, like, even with the advent of Trump, he's like signing out of the Paris Agreement. So, if it's like nobody's acting, as I could see, US isn't acting on climate change. Europe is like kind of taxing other people on climate change, but to protect the intel industries, it doesn't look like they are actually acting or benefiting the third world countries. So, with all of these things, there isn't any unified effort by global countries to combat climate change, especially the developed countries. So, like in the next 2 to 3 years, probably climate change may worsen. So, will it be like the CCUS technology, which is like carbon capture, utilization, and storage? Is it the only viable method to combat climate change, or else? Because as you said earlier, energy transition takes time. Like if you want to deploy a lot of solar panels, stuff like that, it will take some 2 to 3 years probably. And planting trees and down to combat climate change requires a lot of land. And it also takes 4 to 5 years for it to absorb many oxygen from the atmosphere. So is CCUS the ultimate solution? That's another question. And the first question I earlier asked was like, climate change needs a global cooperation, but countries which is like having historically very cold temperature like Canada actually benefits from climate change because it makes them viable to agriculture and stuff like that, which wasn't earlier feasible. So they aren't going to act for climate change. So will the world be divided in this aspect I was asking?
Yeah, it is not like a straight equation, like this, like Canada or in the North Pole or South Pole. If temperature is increasing, they can do plantation or vegetation. It is not like direct equation, right? Because that is a cold country for so many years. Whatever the birds or animals, living beings are adapted to that weather. If you are increasing temperature, they may be viable to may not be able to adapt that weather. Even the people who were living for so many centuries, they may not be adapt to that increased temperature. This is not just straight equation to put like I'm reducing the increasing temperature, reducing the cold weather, so that I can plant the trees. Tree may not be immediately adapt to that weather. So this is not just simple direct equation to put plus or minus, like I'm increasing temperature, reducing the cold temperature, so that I can make more vegetation. It is not like direct fitting. We have to understand that even people they may not ready to adapt warmer temperature, because it is so many years being adapted to that weather, particular region. So the moment we are trying to change it rapidly, it is affecting rapidly everywhere. So that perspective is different. And like living from this kind of policy, like Paris Agreement. So we can't comment on that, because it's initially that government in 2015, whoever was leading the country, they were agreed to that commitment. When the new leader comes, if they are withdrawing, so that is bad way to benefit to the earth. So that maturity has to come at all the leaders, and they should work together. Then only we can solve such a solution. We have to realize what is happening. It is like okay, well, like one country is, why I have to put effort, why I have to pay more tax, or why I have to lend more money to the other countries. If they are thinking like that, we can't comment on that. But it has to be, the maturity has to come at all the stage, all people. Then we can really we can achieve the target, whatever the living beings. This is not only for us. We are discussing about human mortality, but nobody discuss about animal mortality or how other living beings are suffer, because we can't realize how it has happened. Right. So earth is not only for humans, for other living beings also. That we have to realize.
Okay. So we have to wind up quickly because we have been allowed to have this session up to 12:30. So we have a number of questions. Please ask the question briefly. Secondly, it should be a quick question, and moreover, it should be more relevant because it's a wide subject. Meteorology is a very wide subject, and we have a lot of questions about cyclone, all those things. Now, this area is heat waves and other things. Please confine to that. And after that meeting, he will be available. You can approach him and ask all the questions, because I also have several other questions in the meteorology. Better to restrict our questions so that we can conclude the session as early as possible. Please fill up your feedback. Already it's I will not lie.
Yes, sir. This is a very simple question related to heat waves. So recently in the Hindu newspaper and many newspapers, we saw that Chennai recorded a higher temperature in recent winter months. So my question is this concept of heat wave moving more from summer to other seasons? Is it having expanding effects on subsequent seasons, and is it a thing of worry in the future? Is it like going to disrupt the entire season cycle in the long run is my question.
Yeah, certainly answer is yes. Like as I mentioned, like one of my final this conclusion is that early heat wave, when early heat waves is like a winter heat wave. The winter is like expand like from December to February. So this that my unpublished was talking about this early heat wave, like a February heat wave, or what you call it, the winter heat wave. So that we are already studying. So the seasonality is likely to change or it is expanding. You can say that even IMD also published that in over Kerala, south region, it was continuously the warmer the last 6 months. It was continuously every day they were giving high temperature warning. So that was like that is happening. We are also issuing the warnings. This everything we are already in the scenario of climate change.
Yes, sir. Good afternoon. I have simple question. When people say climate varies between minus 1.2 degree to plus 1.2 degree all these years, what we are seeing is minus 2 degree or plus 2 degree, 1.5, 1.7. What does this mean? Is it based on season or something else?
No, at the beginning itself, I mentioned what is plus 1.5 degree. That is the Earth. If you are taking Earth any day, area average over the pole temperature with the two different poles and all the ocean, all the land temperature. If you're taking average, some value is there. Okay, so that is the value we are talking about. During the pre-industrial condition, like industry in the 19th century, right? Pre-industrial, if you are taking last 50 years, 1950 to 1800, average, the Earth average together, temporal and spatial average. What is the value? Then from that value, what is the plus 1.5 degree? That is what Javier Montijo that was 2400 degrees, 1 point plus 1.55 degrees Celsius. Right? So before pre-industrial or during pre-industrial, that was 10.2, whatever I mentioned in the first slide. Now we already reached nearly 15.25 degrees Celsius. So 0.5 degrees Celsius matter because we are talking about the entire Earth value. Because cold region would be the North Pole, South Pole. Then the warm region, the equator belt. If you're adding all together, then if you just 0.5 increases, it's matter a lot. Even just a 0.1 difference in the whole the ice. Is melting ice because something else, like increase in the sea surface height, thermocline circulation will disturb, entire circulation disturb in the ocean, then that will give in the different impact in monsoon, that will give different impacts in cyclone. So all of them interrelate. One changes will give all changes.
So I have a simple questions. Like you said 1.5 is the global average. So will that vary for tropical regions like India? Will that increase or?
That also I pointed out. So it was 0.65.
Okay, so that's 0.65 India.
2024 declared it was a plus 0.65. In 2012 it was, sorry, 2016 it was a 0.5 or something.
Okay.
That also I mentioned in the.
Another question is on aerosol. You said we can create rain using aerosol. So if we create rain in some particular area, will that affect the other area, like where we are supposed to get rain? So whether we are denying rain on that area.
So in the last year in Saudi Arabia, there was a cases. It was not clearly mentioned by the agency where that Gulf area flooded with the water. So I can't comment that, but just by reading newspaper itself, they were controversy. Some were saying that it's a artificial rainfall, aerosols try to feed it. So we forget about other region. Even the local region gives heavy rainfall. So that is like scientists trying to study about that. So we can't comment simply which is correct, which is wrong, because this is not like lab experiment, right? If something trying to do that will give large impact. So people will take precautionary cautious, but it may give different impacts, different teleconnection. Not at a longer period, but maybe at a shorter period. Yes. So we can simulate model also. If suppose if I'm adding more aerosols at some particular region, that can be artificially we can add it into the model, numerical model. So that can be studied. So before doing that stuff, any government do that stuff. But they will they maybe study for the local, but any initiative for any government is general practice, because before doing things they will do artificially. Like artificial means in computer coding we used to do, if I'm adding more aerosols for artificial rain, that what could be the effects. They used to study that, then only they will try to do that. That's what I'm talking.
All right. Okay, it's the time for winding up, and I invite Mr. Verma to give the vote of thanks.
So time is the only constraint. You will have a lot of questions. So while giving the feedback, there is one item is there. You fill up that any further questions are there. You can ask that questions. We'll try to compile those questions and get an answer from the speaker. Okay. And if anybody has not registered, please register also. Okay, because all the future notification will be getting. So, Dr. Arulalan, thank you very much for your patient, delivering the lecture and answering all the questions. And I told you that time is the only constraint. Sir will be available. So, if you have any one-to-one interaction, you can have that. So, thank you very much for the Anna Centenary Library for providing this venue and the facilities. And thank you all for coming and